Hello everyone, welcome to my another YouTube video of Doctor in White. Today we will discuss the oogenesis in detail and in a very short time. Here you're going to learn a lot about the oogenesis. So here we begin. So first, what is oogenesis? Oogenesis is the process of the formation of the female gametes, and it is a type of a gametogenesis followed in women in which the ova or the female gamete are formed, and these female gametes are known as ovum or eggs. So oogenesis is a cycle of female gamete formation, and before conception this cycle starts inside the embryo state itself when the woman is in embryo state, and before the birth the step in oogenesis starts up to the primary oocyte production, and these primary oocytes are not further divided. That means when a woman is in an embryo state there is a formation of the primary oocyte, but this primary oocyte is not going to further divide, it will arrest in that state only. They either become or degenerate, and the oogenesis takes place in the outermost ovary layer, and oogenesis starts with an oogonium-like germ cell and undergoes mitosis to increase the number. Now we will look at the process of the oogenesis, and the process of oogenesis is completed in the following three stages. The first stage is prenatal stage. In this, the primary oocyte grows while at the meiosis 1 being arrested. So that means in this stage in the embryo the primary oocytes grows but stays at the meiosis 1 stage. Here they proliferate and form a stratified cuboidal epithelium around itself. So that means earlier we have a oogonium with us that will be converted into the primary oocyte, and this primary oocyte will have a stratified cuboidal epithelium cell layer around itself, and such cells are referred to as a granulosa cells, and these cells secretes a glycoprotein around the primary oocyte to form a layer called zona pellucida. So that means if this is a primary oocyte, it will have a glycoprotein layer known as zona pellucida. Second stage, we have the anterior stage. In this, the fluid filled space between the granulosa cells merges together to form a central fluid filled space called as antrum. That means the granulosa cells merges together to form a fluid filled space called as antrum. As you can see in the picture, it is a space between this present, and these are referred to as the secondary follicles, and those secondary follicle develops during the monthly cycle under the influence of FSH, that is follicle stimulating hormone, and the LH hormone. Theca externa and theca interna together is known as secondary follicle, whereas in the prenatal stage we have the primary follicle. The third stage is pre-ovulatory stage, that is a stage followed after the puberty hits, and in this the LH surge induces this stage, and the meiosis 1 completes here, which is what arrested in the embryo stage, and inside this the follicles are formed two haploid cells of the unequal size. So first haploid cell is known as the polar body, which has a less cytoplasm, and this cannot be involved in the development of the ovum. And the second haploid cell is a secondary oocyte known as the other daughter cell, and here the meiosis 2 occurs in the both daughter cells. The polar body replicates to form two more polar body. As you can see, first polar body divides and form two other polar bodies, whereas the secondary oocyte arrests in the meiosis 2 stage in the metaphase stage for the weight of the fertilization. So through this diagram we are going to more know about the oogenesis in a better way. So we have a stage before the birth. In this we have a diploid cells known as oogonium, which is going to divide mitotically. So it will form the first oocyte, that is the primary oocyte, and this primary oocyte will have a zona pellucida layer around itself, and it will not further divide, and it will stay arrested in the stage of meiosis 1, that is prophase, and prophase, that is diploid. So after the puberty hits there is a completion of the meiosis 1 and onset of the meiosis 2. So each month we have a secondary oocyte converted by a primary oocyte, and we also have a first polar body. So they are having two daughter cells after primary oocyte, one with the more cytoplasm and other with the less cytoplasm. Here the first polar body will complete the meiosis 2 stage and form the other two polar body that are not functionally active in the development of the ovum, but this secondary oocyte remain arrested in the metaphase meiosis 2 stage until there is an entry of the sperm and there is an occurrence of the ovulation. So after the ovulation there is a release of the secondary oocyte from the ovaries, and there we have a fertilized egg, and here the meiosis 2 ended and the cell is grown. And this secondary oocyte will also form a second polar body here. So we started with the oogonium with the 46 chromosome, that is 2n, that will divide and forms the primary oocyte that is also diploid. But after meiosis 1, this will form first polar body and the secondary oocyte. First polar body will be converted and complete the meiosis 2 stage, forming the two polar bodies, while the secondary oocyte remain in the metaphase a rest of the meiosis 1 until the sperm entry, and after the sperm entry it will form one polar body and one fertilized egg. Now we will see the development of the follicle. So first we have the primary follicle. In this, the primary oocyte is surrounded by a granulosa cell known as theca, and we have a small cavities are observed. So as you can see in the picture, the conversion of the oogonium to the primary oocyte, and this primary oocyte will have a granulosa cell layer, and this layer will be known as the primary follicle layer. So we have a primary follicle layer on the primary oocytes. Second, we have the secondary follicles. In this, we have the secondary oocyte surrounded by two cell layers, theca externa and theca interna, and here the small cavity observed in the primary follicle becomes large and known as the antrum. As you can see in the picture, the primary follicle layer gets grow, and in the secondary oocyte it will form a secondary follicle, and this will also have a large antrum. The tertiary follicles are also known as graphene follicles and contains a secondary oocyte. Here the large antrum is filled with the fluid, and this graphene follicle ruptures due to the LH surge and the secondary oocyte is released. So here we have to understand this primary follicle is converted into the secondary follicle, and the secondary follicle will be converted into the tertiary follicle, and here the cavity becomes more large and get filled with the fluid, and due to the LH surge the graphene follicles ruptures and releases the secondary oocyte for the pre-ovulatory stage. So first you can see the primary follicle which will grow and start in having an initial cavity of the antrum. In third we can see the secondary follicle, and third we can see the tertiary follicle. Here we have primary, here we have secondary, here we have tertiary or the graphene follicle, and due to the LH surge there is a release of secondary oocyte. Thank you everyone for watching my video. If you do like my video, please don't forget to subscribe the channel Dr. in White, and please like and comment.